In this question, we are having the magnitude of magnetic field of an electromagnetic wave as 3 into 10 raised to minus 8 sine omega t plus kx plus phi j cap. Now we have to find the corresponding electric field associated. So in an electromagnetic wave, we know that electric and magnetic field vectors are oscillating in a mutually perpendicular direction. In order to find the electric field component, we have to apply the relation C equal to E over B, where E is the electric field vector and B is the magnetic field vector. From this, we can write E is equal to C times B. Now, C is the velocity of electromagnetic wave in vacuum, which is 3 into 10 raised to 8 meter per second. So from that, E is equal to 3 into 10 raised to 8 multiplied by 3 into 10 raised to minus 8, which yields 9. Therefore, the answer is of the form E equal to E naught sine omega t plus kx plus phi. So we have to replace E naught with 9. So E is equal to 9 sine omega t plus kx plus phi k cap. That is option 2 is the correct answer. In this question, we are having a series LCR circuit and we have to find the analogous values for the self-inductance, capacitance and resistance in a mechanical system. So in a mechanical oscillator which executes damped oscillations, we have the net force, that is MA, is equal to the restoring force plus the damping force, where B is the damping constant and V is the velocity of the oscillator. So for an oscillator of mass M and force constant K executing damped oscillations in a medium with damping constant B, we have the net force is equal to the sum of the elastic restoring force and the damping force. So we can write MA, which is d square x by dt square, where x is the position in terms of displacement from the mean position, is equal to, on taking to the right side, plus bv plus kx is equal to 0. This is the differential equation for a damped harmonic oscillator. You can modify it by writing as d square x by dt square plus b by m dx by dt plus kx is equal to 0. Now v is dx by dt. Now in a series LCR circuit, means a charged capacitor will be discharging through an inductor and resistor in series. LC oscillations takes place, which is also a damped oscillation. Now writing the equation by Kirchhoff's second law, we have L di by dt plus Ri, the potential difference across resistance, plus the potential difference across the capacitor Q by C is equal to 0. There is the algebraic sum of EMF and potential difference along a closed path equal to 0. Now I is dq by dt, where q is the electric charge. So L d square q by dt square plus R dq by dt plus q by c is equal to 0. This equation is very much comparable with this equation, from which we know that the equivalent of mass in an electrical oscillator is self-inductance. The equivalent of the damping constant in an electrical circuit, LCR series circuit, is electrical resistance, and the equivalent of the force constant is 1 by C, the reciprocal of capacitance. So the answer is option 2. In this question, a lift can hold a maximum of 2000 kilogram mass. The frictional force is provided as 4000 Newton, and we have a motor of 60 horsepower, and we have to find the maximum velocity with which the lift can move upwards. So when the lift is moving upwards, it has to work against the force due to the frictional force, which is downwards, as well as the total weight due to the 2000 kilogram mass. So the net force downward will be 2000 kilogram weight, which is 2000 multiplied by 10, 20,000 Newton downwards, plus 4000 Newton downwards. Now the 60 HP motor is providing an upward force. 1 horsepower is equal to 746 watts. So the power upwards is 60 multiplied by 746. Now we have to find the maximum velocity with which the lift can move upwards. So we will use a direct formula. Power is equal to force multiplied by velocity. Now the power is provided by the 60 HP motor, so 60 multiplied by 746 is equal to the force. It has to oppose the frictional force, 4000 multiplied by V, plus the 20 kilogram weight, which is 20,000 Newton, multiplied by V. Solving, we have V is equal to 60 multiplied by 746 divided by 24,000. So the answer is approximately 1.86 meter per second. So the answer option is 1.9, option 1. In this question, we have the magnification of a compound microscope as 350. The length of the tube is given as 150 mm, and the focal length of the objective is given as 5 mm. We have to find the focal length of the eyepiece. So we have a question from ray optics, optical instruments, which is a direct substitution for the magnification formula. So the magnifying power is given by L divided by FO into 1 plus D divided by FE. Substituting the values, 375 is equal to 150 divided by 5 multiplied by 1 plus D. Considering the final image to be formed at the least distance of distinct vision, we have 25 divided by FE. Solving which, we have FE is equal to 2.17 centimeter, which is approximately equal to 22 millimeter. So the answer is 22 millimeter. Now another method. Considering the image to be formed at infinity, we have the formula as M is equal to L divided by FO multiplied by D by FE. In that case, the answer comes much nearer, which is 22 millimeter. Since the answer options are not closely placed values, you can easily arrive at the answer as option 22 millimeter.